Welcome back, folks. So what we're going to do today is we're going to have a look at addressing an issue with this little power supply. Now, it's a fine little power supply. I did a video on it and tested it out. But one of the things that I noticed in all of that, this power supply just has a single output from the transformer. It doesn't, like most sophisticated supplies, as you turn up the voltage on it, it switches different windings in the power supply so that the dissipation of the pass element is reduced. This doesn't have that, so it just has the one output. It produces over 20 volts before regulation, and that means when you're running this down around about 2 volts and you're drawing 2 amps on it, you're dissipating in excess of 40 watts. And while this transistor can dissipate 150 watts, it needs sufficient heat sinking to do that. As it is now, it is just attached to a very thin metal casing, which is not enough heat sinking. When it's down at 2 volts and you're drawing 2 amps on it, this thing gets too hot to touch within seconds. So what we're going to do, we're going to try and install this heat sink here, which is plenty to dissipate 40 watts and keep this transistor cool enough. So that's the idea about this project. Now, one of the unfortunate things about this is I don't have a new mounting kit for it, which includes the little thermal gasket here. So I'm going to have to be very careful about removing that. If I can't remove this without destroying that, we're kind of stuck in the water. But we'll see how that goes. So let me speed up through getting the case open to see what we're going to do about removing the transistor, whether or not we have enough length in the wires in order to be able to extend this out. It looks like it needs to come out about another 3/4 of an inch. So let's get to that. Okay, it looks like if we take the wires out of this bundle, there should be no problem at all extending them out far enough and create their own little bundle. That should be fine. So let's quickly remove this transistor. It looks like I'm going to have to cut some heat shrink here and apply new heat shrink on this side. You may also have to drill a bigger hole here to get all these wires through, but I have to be really careful in removing the transistor. So yeah, I'm going to get started on that. Okay, looks like we were able to get this kit off nicely, which is good. I'm going to have to probably clean up those threads a little bit, but other than that, we should be okay. Now, in order to get the pattern for drilling the holes, I've got this this little sticker here. So all I'm going to do is put this over the pattern here, and then it's going to transfer it on. There we go. Now these ones here have a very specific size in order to be not too loose. But I think I'm going to make the ones for the leads, the emitter and base, much bigger than what they made them, just so we have lots of clearance room. So I'm going to drill this up, and I'll be right back. All right, so there I've got the template drilled out, the pattern's drilled out, and I use 11/64 for these holes here, yeah, which is the right size for these little plastic spacers. They fit nicely and snugly in there. And I use 1/4 inch for these to allow lots and lots of room for the leads to come through. So once everything is all lined up, we got a ton of space there. You have to straighten out these leads a little bit to get them in the middle, but yeah, it's going to be lots of room there, so we won't have to worry. Plus, we'll be putting the heat shrink right up to the base of the transistor there. Oh, I should say right up to the glass insulators. This is the base, this is the collector or emitter. All right, so let me try and mount this thing up, and we'll come right back. Now, one of the things I like to do, most people say you shouldn't have to do it, and I know you shouldn't have to do it, but I'll take a very, very, very tiny amount of thermal compound, just the slightest amount, and I'll spread it all over this, just to increase the contact area through a thermal substance. Now, as most of you are correct in saying, it's not entirely necessary, but it's not going to hurt anything either, especially when it's so thin you can't even see it. But it will provide that initial additional contact. Now what I'm going to do to mount the heatsink on here is I'm just going to clamp this down here with a clamp and then mark out some spots here to get the thing drilled, and then I'm just going to drill the two pieces together and where the holes will line up perfectly. So let me do that and I'll come back. Okay, I've got all that drilled out and ready to go, and really lucky. I found some really nice screws to hold this thing down here, and they've got Robertson heads on them. These are the best heads. You know, you put them on the screwdriver, they stay on there, and you can get them into place there, and they're a square head, so they never strip. Anyway, so I've also widened one of the holes, the ones closer to the terminals here in the back, and I'm going to put a grommet in that because we're going to bring the wires through there. It's just a rubber grommet. Okay, and what I also decided to do, rather than serenade my neighbors with a lot of cursing and other bad language, what I'm going to do is I'm actually going to put on wires on here, and then I'm going to make the connection internally. So I'll be using, you know, I'll just solder them up and use a little bit of heat shrink in here to keep them nice. That'll avoid a heck of a lot of you know, profanity on my part. And so I'm going to mount everything up, and then I'll come back and show you the end result, which shouldn't be too complicated, too long. So this whole thing has taken, we're into it about half an hour or so. So this is not taking too long. So anyway, let me do that little bit, and we'll come right back and show you where we are. Okay, so I've got the transistors all mounted up now to the heatsink, and I'm just going to do some sanity checks here to make sure that things aren't shorted out. So I'll check between the transistor itself and the heatsink. So that looks pretty good. Now I need to be able to have continuity though to the white wire here. And I do. Let's put this on make it beep at me. That's good. There should be none here. Yeah, none here, at least not that direction. Okay. So everything seems to be okay. I'm going to go ahead then and mount it up and then wire these. I didn't have exactly the same colors, unfortunately, but the white will go to the yellow, the red will go to the red, and the black will go to the blue. And the blue is the emitter, this is the base, and of course that's the collector. Okay, so here's what it looks like. I've got everything hooked up, and I've got the heatsink mounted up, both on the transistor and on the heatsink. I used a little drop of blue Loctite just to help with the keeping the screws done up as they thermally expand and contract. Don't know how much that will help. Will help a little bit, but and I've done my sanity checks. Everything is okay. And here, I wanted to show you. I made a comment earlier about Robertson screws. I mean, they're just the best for electronic assembly, and I'll show you why. I know everybody's got magnetic screwdrivers, but this is a heck of a lot better than a magnetic screwdriver. Like it just doesn't. You can jam this in and use it to wedge a piece of metal out of the way and stuff like that. This is, if you can get them. I know it's difficult to get them outside of Canada, but I did notice that the National Park Service is gone exclusively to using Robertson screws for putting together their boardwalks and stuff like that these days. So if they can get them, you can probably get them, even if you have to get onto some online to someplace in Canada and order them down. But once you try Robertson screws, you're never going to want to go back to Phillips or Slotted. They're just absolutely the best. And another thing I had to do was this little screw here, because of the thickness of this, wasn't long enough. So I had to go through my little thing here of random screws. And so that's another thing I wanted to mention. Anybody who's been at this a long time realizes you never throw away hardware. Like if you take something apart and throw the rest of it away, that's fine. But keep the hardware. There's so many different sizes and threads and everything else, metric and imperial. There's no way you can stock enough hardware to meet your needs. So this is the only way to do it, is to salvage it. Yeah, throw the rest away, keep your hardware. Most important thing. So I'll keep that one screw that I took out. And now I'm ready to hook this up and see if it explodes. And I'm going to plug the cable in, keeping my hands away from anything with a high potential. Nothing is burnt up yet. Let me get a load on this. I'm going to put a 2 ohm load on it. I'm bringing down to 4 volts. That'll give me into 2 ohms. And we'll check the... Yeah, so we'll try 4 volts at 2 ohms. That'll give us 2 amps at about 18 or 19 volts across the transistor. And we'll hook this up and then we'll adjust the current. So it looks like, yeah, we're at, I don't know if you can see that, we're at 1.7 amps. Let's put that right up. So let's put a hand on the transistor at the back here. And you know, it's not even getting warm. Well, it's getting warm, but slowly. It might be around, I don't know, maybe 35 degrees right now, 40 degrees. Just guesstimating by my fingers. I can certainly hold my hand here all day. And it doesn't seem to be getting much warmer than that. The heatsink itself is not heating up yet. Yeah, that's going to be fine. That's going to be absolutely fine. So other than that little glitch, 50 or 60, 70 nanoseconds when it turns on and off, and it's a tiny glitch, like it's not a horrible overshoot or undershoot of several volts. It's like maybe 100 millivolts and maybe 70 nanoseconds long. Now, other than that, I think I've solved all the issues that I had with this power supply, and that was really the only 2 issues. Was this transistor heat sinking was just wholly inadequate, and that little glitch, and I'm not worried about the little glitch. That's not going to do anything. So that's good. I am happy with that. And we're heating up the resistor a heck of a lot more than we're heating up the transistor. So yeah, that's fine. There's no issue there at all. Wonderful. All right, guys. Catch you in the next one.